All right, sorry that last video got a little bit cut off, so let's just continue from where we left off there. We were taking the derivative with respect to t of both sides here. So on the left side, we get g prime of t. Now on the right side, we're taking the derivative of big F, so we of course get big F prime of x, but we have to be very careful because x is itself a function. It's a function with respect to t. So this is really like saying times x prime. Okay, but you know we have so many we have three variables here, x, y, and t. So it's important to really clarify. So I'm going to write it this way: g prime of t is equal to big F with respect to x times x prime. But x prime is really little f prime of t. Okay. And now we're going to just rearrange a few things, and we will get g prime of t over little f prime of t is equal to big F prime of x. And it's helpful really to rewrite this in a slightly different notation. And again, I'm not changing the meaning here. All I'm really doing is rewriting this a different way. The symbol here means equivalent. So g prime of t is the derivative of y, right, with respect to t. So we can write this as dy dt over little f prime of t. But f prime is really the derivative of x with respect to t. So I get dx dt. And over here I get big F prime of x, but f is really just a function relating x and y. So this is like saying dy dx. Okay. So this version here is what you're most likely to see in textbooks and perhaps even on exams. And this says that if you want to know the derivative of y with respect to x, you could take the derivative of y with respect to t and divide it by the derivative of x with respect to t. And now I'm going to show you why this this method and why writing it in this way really helps us simplify a lot of our problems. Okay. So looking back at example 3 from before, we were asked this question: given x equals 2t minus 3 y equals t cubed, find the change in y over the change in x when t is equal to 4. Okay. So and last time we had to eliminate the parameter, plug in, do a lot of substitution, but now watch how much simpler this is. So we're going to use this rule that dy dx is equal to dy dt over dx dt. Okay, dy dx. And these are derivatives here. A lot of people treat these plainly as fractions, and they're not quite correct. Okay, so we have to treat these as derivatives. So dy dx is equal to the derivative of y with respect to t. So, you know, if I were to take this function here and, you know, find the derivative of y with respect to t, I would get 3t squared. Okay, so this is equal to 3t squared over dx dt. So the derivative of x with respect to t. So dx dt in this case is equal to 2. Okay, that's simple enough. So all of this is equal to is over 2. Now then, when I go to answer the question, you know, dy dx when t is equal to 4, much simpler process. Just do some substitution. 3 times 4 squared over 2, and this gives me 48 in the numerator, 2 in the denominator, so that comes out to 24. And it's important, again, not to lose track of what we're trying to do. Remember that when I graph this parametric equation, I get this graph. And this 24 basically says that, let me show you here, that, that's kind of hard to see, hopefully that's better, that when t is equal to 4, x is equal to 5, y is equal to 64, so at that point, that the tangent line right there has a slope of 24. Okay? So t helps us figure out how fast, or how fast this graph changes with respect to time, but in terms of its slope, y and x, it's still 24. Okay? And at the moment when time is equal to 4, the slope of this graph is equal to 24. So that's a little bit of interpretation and meaning there. Thank you for watching, and please have a wonderful day.